So we're going to look at the chapter on bond pricing, chapter 6. So what we're going to look at is, first of all, what is a bond? What are the terms of the bond contract? What are the elements of the contract that we can use to price our bond? So there are two ways in which a firm can raise capital from the markets. When a firm starts, it starts with some capital. When a business starts, it starts with the entrepreneur investing some of their own capital into the firm, and then they grow the firm. After a while, the firm gets successful enough that now it can attract external capital to finance its ongoing growth. And one of the ways in which they can use markets to raise capital is by selling bonds. Bonds are debt instruments, meaning they are designed as just a straight loan. Essentially, the firm is taking out a loan from not a single bank, but from a collection of bondholders. So collectively, all of the bondholders together are providing a loan to the firm. So the firm has to first decide what's the size of their loan offering? What's the size of the loan they want to take? $1 million, $50 million, $100 million, whatever. Once they make that decision, then they start selling bonds to raise that capital. Typically, a bond would have a face value of $1,000 if it's a corporate bond. Face value means this is the principal of the bond. This is the principal of the loan, which means this principal is to be paid back at the end of the term of the loan. So it works slightly different than a typical debt instrument that we saw in the last chapter with a typical mortgage loan, but this works slightly different. So the face value is the value of the bond that is imprinted on the face of the bond. That's why it's called the face value. And this is the value that must be paid back to the bondholders when the bond matures. Now, in addition, the bondholders will be receiving periodic interest rate, and that interest rate is set by the coupon amount of the bond. So in addition to the face value, we have to know something called the coupon amount. And the coupon amount is equal to the coupon rate that will be stated on the bond contract multiplied by the face value. So if the coupon rate is 5% and face value is 1,000, then the periodic coupon amount would be $50 per year, if the coupon rate is generally stated in annual terms. So those are the payments that will be made over the life of the bond. So face value, again, it's also known as the par value or the principal amount, as I just discussed. And it's the notional amount that is used to compute the interest rate, and it will be paid back at the end of the life of the bond, repaid at maturity. Coupons are based on this notional amount or the par value, calculated as coupon rate times the face value. The coupon rate is set by the issuer, and it must be stated on the bond. Being a debt contract, that means once this is set, it's not going to change over the life of the bond. And it is stated in APR, so that the coupon amount becomes the coupon rate times the face value divided by the number of coupon payments per year. If the coupon payments are annual, then this would imply one coupon payment per year. If the coupon payments are semi-annual, which is more typical, then that would imply 2 coupon payments per year. Okay. Now, on the bond certificate itself, what are the things that are stated? And this bond certificate essentially is the contract. And it functions exactly like a contract between the firm and the bondholders. And being a contract, the terms of the contract dictate the rights and obligations of both sides. So what does the bond certificate state? It states the amounts and the dates of all of the payment. In addition, it states what the firm can do or cannot do with that money. Because think about it in the following manner, that you as a bondholder, you are giving a loan to the bank, to the firm today. Now, the firm receives the loan, takes that loan. What is the guarantee that the firm will do what they promised you to do? And one of the ways that's guaranteed by the firm, that in other words, it will not take that money and abuse that money, one of the ways it is guaranteed is through this bond certificate, also known as the bond covenant. It states the coupons, the promised interest payments, periodic interest payments. It has to also state the number of payments per year and the coupon rate. It has to state the maturity date, which is the final date on which the principal would be repaid. It has to state the principal or face value, typically $1,000 for corporate bonds. For treasuries, which are issued by the US government, they can be higher, up to $100,000. And then the term, the date of maturity. And thus, you will, from this maturity date, at any given point, you will then be able to figure out what the term is, the time remaining until the bond matures or the principal is paid back. There are different types of coupons. Coupon rate can be anything up to and including 0. If the coupon rate is 0, then the bond essentially has no interim cash flow. So at time 0, the bond is issued, and then at time t, which is maturity, the bond will pay back its principal. Let's assume that to be 1,000. We can call that also FV, this time indicating that FV is face value, not necessarily future value. It's both future value and face value, but let's think of that as face value. Now, what we will do to price this, of course, what will be the price of this bond today? Let's call that B0, indicating this is the price of the bond at time 0. Price of the bond today essentially will be present value of that face value of 1,000, depending upon what the interest rate is and how much time is left to maturity. Treasury bills, which are issued by the US government for as short-term debt instruments, and that have a maturity of up to 1 year. They can be 3-month, 6-month, 9-month maturity, up to a year. They are usually zero coupon bonds, meaning the bonds are sold at a discount today, and then at maturity, you receive the face value of the bond, typically $100,000. So here is a 1 year, and as we talked about in the previous chapter, treasuries are regarded as risk-free. So bear that in mind. It's a zero coupon bond. It has a face value of 100,000. If you purchase the bond at this price and you are receiving this value at maturity, the 100,000 at maturity over 1 year, then what is your rate of return on this investment? So one of the ways in which we can do this is using our financial calculator. So we treat the 100,000 as future value, 96,618 as present value, n as 1. And what are we missing? We're missing IY, so we will compute IY. So we can do this. Clear, second, clear TVM. Okay, so we have 100,000 as our future value, 96,618.36 change sign, present value, n is equal to 1. I compute IY. So that's 3.5%. Okay. So my rate of return from this investment is 3.5%. And this rate of return we call yield to maturity. In bond terms, the rate of return that we get from investing in a bond today and holding the bond all the way till maturity. I invest in this bond today, and I'm holding it all the way till maturity. What's the rate of return on my investment? That rate of return is called yield to maturity. What is typically viewed as return in bond terminology, we call it yield. And that yield is essentially calculated in the following manner. 1 plus the yield to maturity over n periods is the face value of the bond, which is the future value, divided by the present value. I raise it to the power 1 over n. There's no big mystery to this equation. If you recall, present value is future value at period n times 1 plus r to the power n. Then 1 plus r to the power n is I made the mistake over here. Let me restate this. This should be, I stated the opposite. This should be future value at period n, should be present value times that. So this would be FVN divided by PV. Then 1 plus R would be FVN, future value at period n, divided by PV, the whole thing raised to the power 1 over n. And that's all what we are doing in the calculator. We are solving for this equation. And this R, since this is the rate of return over this period of time, in the context of bond terminology, we call that the yield to maturity. So here we have different zero coupon bonds with a face value or par value of 100. So that's my future value. These are my present values, right? These are the present value for a 2-year bond, for a 1-year bond, and so on and so forth. And from this, we can calculate yield to maturity. If it's a 1-year bond, yield to maturity is 3.5. If it's a 2-year bond, in other words, we would do future value as 100, present value as negative 92.45, n is equal to 2, compute IY, which would be 4%. Okay. Similarly, you can practice some more problems available on the PowerPoint slides. You can download them and practice them. I talked a little bit about risk-free interest rate in the context of the interest rate chapter, but this is a good idea to revisit them. Because the zero coupon bonds are default free. They're default free in a sense that once the US government or a sovereign government that has full control over issuing currency, issues a bond, then that bond, the nominal value of the bond is the par value of the bond. This par value is guaranteed to be paid back by the government when the bond matures. How can the government guarantee this? They can guarantee the nominal value back because either the government will have the money in its treasury to pay you back, and if the government does not have that money to pay you back, they can always print currency and pay you back. And so in that sense, zero coupon bonds are, the key word here is default free. So thus they are considered risk-free in a sense that they are default free. Okay. So when a bond is of shorter maturity, we would expect them to have lower yield. And if the bond is of higher maturity, we will expect them to have higher yield. This is assuming, as we have talked about last class, that the term structure of interest is upward sloping, as we can see over here. Okay. So now let's skip over that. You can practice some of these bonds. Let's go to the next type of bond, which are called coupon bonds. In a coupon bond, it works just like a zero coupon bond. At time zero, the bond is being issued. At maturity, we are expecting the face value of the bond back. This is at maturity. But then we have interim cash flows. We have cash flows in the interim between now and maturity. Let's say it's 1, 2, 3, then dot, 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 all the way to period T, where T could be any number. In that interim time period, the bond will pay back its coupon of C, including the final C at maturity. These C's are the coupon amounts. And they are calculated, as we have talked about before, C% of the face value or the par value. So if coupon rate is 5%, face value is 100, then each of those cash flows of C is $5. In other words, a coupon payment, in addition to paying back the face value at maturity, it will pay back regular coupon interest payment over the life of the bond. The treasuries that are coupon payment, that have positive coupon payment, are treasury notes and treasury bonds. Treasury notes have maturities between 1 to 10 years, and treasury bonds have maturities greater than 10 years, about typically 10 to 30 years. Okay. So how do we calculate the price of a bond like that? So let's take an example over here. $1,000 of par value, which tells us that at maturity, the investor would be paid back $1,000. It has a coupon of 2.2%. And the key part over here, you have to make a note to find out whether the coupon payments are annual or semi-annual. Over here, it states it is semi-annual, meaning that there will be 2 coupon payments per year. So in the context of a timeline like this, there will be not just 1 coupon payment, there will be 2 coupon payments. That will be a total of C. That means C over 2 will be paid back every 6 months. So C over 2, 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 and then C over 2. Every 6 months, C over 2 will be paid back, and so on and so forth. So that's what's key about figuring this out, whether it's 1 coupon payment per year or 2 coupon payments per year. And the coupon payment will be 2.2% of face value. That means it will be 2.2% of $1,000. That means it will be $22. $22 per year. Since it is semi-annual, it will be 22 divided by 2, or $11 every 6 months. So that's what we have over here. $11 every 6 months, all the way till maturity, plus the $1,000 at the end of the 6th month. So how do we price this thing? So we price this thing by looking at, let me use it over here. So we will make payment as 11. Why is it payment? Because if you look at this stream of $11 payments, this stream of $11 payments are like a annuity. Then in addition, I have this one-time cash flow of 1,000. which is like my future value. So my payment is 11. Then I have future value as 1,000. How many periods do I have between today and maturity? So today is 2010 and it matures in May 2015. So that means there are 5 years to maturity. If there are 5 years to maturity, there are a total of 10 cash flows to maturity. 5 years, 2 payments per year. So it's 5 years multiplied by 2. That means it's 10 payments per year. So number of periods, N, will be 10, which is 5 times 2. Payment was 11, which is 22 divided by 2. Just to make note of everything over here. We have future value. Now what do we need? We need to know what is if we can find out what the prevailing interest rate is, IY, if we can find that out, if I can find that out, it's a question mark right now, then I should be able to compute my present value, which will give me the bond price. So in this problem right now, this information is missing. They have only, because at this point, they're only asking us to figure out the cash flows of a coupon bond or note. So we have laid out the cash flows over here. Annuity stream of $11, final cash flow of $1,000, cash flows occurring over a 10-year period. Okay. Now the only thing that we are missing over here is IY. What's the discount rate? We don't know this. So later on we will find out what the discount rate is, and then we can price the bond. Okay. So the price of a bond essentially consists of 2 parts. The first part is an annuity. This is the present value of an annuity. And the second part is the present value of a one-time cash flow of FV. So we can either use the formula approach. This is our coupon. We have to figure out what the yield to maturity is, future value. So coupon and future value, they're stated by contract, as is the number of periods. What's the only thing that we have to come up as an estimate? We have to estimate what the yield to maturity is. If I can find out what the yield to maturity is, then I should be able to price the bond. Now, what should yield to maturity look like? What should YTM look like? Yield to maturity should be the required rate of return. The return that investors are requiring to invest in this bond. Remember, in a bond, this is the investment sequence that is happening. Bondholders are providing this payment of B0 today. In exchange, bondholders are being promised periodic payments of coupon, whether it's 6 months or yearly, does not matter. Periodic payments of a coupon, and then in the final year, they are being promised a face value of FV. So the bondholders will have to invest in this bond today. They have to make a decision whether to buy the bond or not. This decision depends upon, as we can see in this formula, the present value depends upon the yield to maturity, meaning at what rate am I discounting these cash flows? All of these cash flows are being discounted to the present. What is the rate at which these cash flows are being discounted? That's what yield to maturity is telling me. And what rate should it be discounted? It should be discounted at the rate of what we call the required rate of return. Based on the riskiness of this investment, what is the rate of return investors require from this investment? That's the rate at which it should be discounted. Once we can impute that, then we can calculate the bond price. P or B0, whichever. I like to use B0 because it indicates B, bond, and 0 indicating that this is being priced at time 0 today. So over here, the problem is somewhat inverted. 5-year bond, that means that's my N. $1,000 par value, that's my FV. 2.2% coupon, that's my C percent. Semi-annual, that's the key. If the bond is trading at 963.11, that means B0 is given. What is YTM? What is yield to maturity? So what do I do? Future value, 1,000. Number of periods, it's 5 years, but since it is semi-annual, I have to multiply that by 2, which is 10. Payment, which is the annuity coupon, is 2.2% of $1,000 is $22. But again, it is semi-annual, so I will divide that by 2, which is 11. And present value, which is the price of the bond, B0, is 963.11. Once I have this, what will I do? I'll compute IY, which will be my yield to maturity. So here I go, second clear TVM, $1,000 FV, 10 is my N, 11 is my payment, 963.11. I have to change sign, that has to be negative, present value. I will compute IY, 1.5%. So I compute IY, that comes out to 1.5%. But this is 1.5% every 6 months. To get my annual YTM, I have to take 1.5, multiply that by 2. That will give me a yield to maturity of 3%. So that's essentially what we are having. We are trying to essentially, this is our B0, this is C over 2, this is N times 2, this is my future value. What's my unknown? I'm solving for Y. So it's 1.5% as we just did, but we have to then multiply this by 2 because it was a semi-annual bond. Okay. So this N is 5 times 2. This 11 is 22 divided by 2. And this has to be 1.5 multiplied by 2 would be 3%. So yield to maturity is 3%. So you can practice some of the other examples that are given over here, calculating yield to maturity or calculating bond prices. So let me stop over here and we'll continue with the second part in a minute.